Welcome to Study Loop.
All right, so part A has to do with energy conservation. We said that the initial energy, E initial, will be equal to the final energy, E final. And so initially you have electrostatic force, which gives an electrostatic energy, so QV, V being the voltage, is equal, and that is converted to kinetic energy of 1/2 mv squared. Therefore, we make small v, velocity, the subject, and so it is square root of 2qv over m. Now we plug in values. This is 2 times elementary charge, so it's 2 times 1.6 times 10 to the negative 19 coulombs, times voltage, which is 3,700 volts, over the mass, which is 6.6 times 10 to the negative 27 kilograms. And so this gives us a velocity of very close to 6.0 times 10 to the 5 meters per second. That's part A. In part B, we're equating forces. So the maximum maximum magnetic force, F max sub B, will be equal to the centripetal force, so Fc. In other words, QVB, which is the maximum force due to the magnetic field, equals mv squared over r, the centripetal force. Therefore, we can make r the subject, which is what we want here. So r will be mv over, by the way, this v here, qv when qvb, that's the same as this v here, which is the velocity. So r is mv over qb. And so plug in the values. We have r equals mass 6.6 times 10 to the negative 27 kilograms times velocity, which we found to be 6.0, approximately 6.0 times 10 to the 5 meters per second, over charge, which is 2 times elementary charge, 1.6 times 10 to the negative 19 coulombs, times B, the magnetic field strength, which is 0.340 Tesla, giving a radius of curvature of 3.63 times 10 to the negative 2 meters. In other words, 3.6 centimeters. And then finally, in part C, we want the period of revolution. And to do that, we use the fact that velocity is equal to distance over time over one period. So distance traveled in one period is 2 pi r, the circumference of the circle. So t, time, will be 2 pi r over v, velocity. So this is 2 pi times 3.63 times 10 to the negative 2 meters over velocity, which is 6.0 times 10 to the 5 meters per second. And so this gives us a time period of 3.8 times 10 to the negative 7 seconds, or 0.38 microseconds.